Okay, today we're going to be talking about simplifying negative exponents. So far we have been using our multiplication of exponents property, and we've gotten the negative exponents, and we've done things like if we had 3a to the negative second, all of that raised to the third. We were able to distribute this third power to both to be able to get 3 to the third, a to the negative sixth, which would then simplify down to 27a to the negative sixth. And up until now, we've left this as it is, and I just kept telling you there's going to be a way for us to simplify this negative exponent. Well, today is the day we're really going to dive into how do we simplify this negative exponent. Before we go on, I just want to remind you that any number raised to the zero power, we learned that today in class, is 1. So keep that in mind in case you see some of those. Okay. Any non-zero number that is raised to a negative exponent is equal to 1 divided by that number. And so if we think about this 3 to the negative 2 as a fraction to start off with, what happens is we're really just moving this 3 to the negative 2 down to the bottom. And so instead of it being 3 to the negative 2 over 1, we're really going to move it down so that it's 1 over 3 to the second. By moving this from the top to the bottom of the fraction, it changes that exponent from a negative to a positive. And now we can recognize 3 to the second power, and we can simplify that down as 1 to the ninth. Same thing with this one. It was 2 to the negative fourth over 1. By moving this down to the bottom, the exponent then becomes positive. Now we have 1 over 2 to the fourth power. So when we see problems like this, our challenge now is going to be to put this into a fraction and moving this down to the bottom so that the exponent becomes positive. Remember, we're only doing these with the negative exponents. So let's look at an example. First example, starting off very basic. We have 2 to the negative third power. With it being 2 to the negative third power, we know that that is the same as 2 to the negative third power over 1. We're now going to take this and move it to the bottom. And when we do that, the exponent then becomes positive. It is of note that we can't really compute this 2 to the negative third power without being able to simplify it. We know how to calculate 2 to the third power, but when those exponents become negative, there's nothing we can do with it until we find a way to make that exponent positive. By moving it to the bottom, now the exponent has become positive. And now we can take this one step further and simplify it and say 2 to the third power is 8. Looking at example number 2, I'll do this one in red. We have a negative number to a negative exponent. Now, remember, this is over 1, but also keep in mind that the rule doesn't say that the base number is going to lose its value or its negative sign. It's simply the exponent. So we don't look at this to try to determine whether or not the exponent or the base number needs to be moved. We look at its exponent. Because this exponent is a negative 4, we know that we have to move this to the bottom. When we move it, there's nothing on top, which we hold that place value as a 1. And then when we move it to the bottom, it's still negative 3, but our exponent, which is what we're trying to do, changes to a positive 4. With that changing to a positive 4, we now know how to be able to simplify this. To take negative 3 times negative 3 times negative 3 times negative 3. And when we do that, we get 81, and so it's 1 over 81. Let's try another example. 3y to the negative second. Now this one's a little bit more difficult because now we have two base numbers. We need to see these as two individual things. We have 3, and then we have a y to the negative second. Okay? The reason why we want to look at these as two individual things is because there's really only one of them that we have a problem with. The one that we have a problem with that isn't simplified is this one, because it has this negative exponent. So again, this whole thing is going to be equivalent to putting it over 1. But now we're trying to get rid of this negative 2, which means we have to move it to the bottom. Now keep in mind, we're just trying to fix the problem. The only problem that we have here is this negative exponent. The 3 is fine. It has a positive exponent of 1. So the 3 then stays up top, but we're fixing the negative exponent by moving it to the bottom, and now the exponent goes from negative to positive, and we have y to the second. So our answer is simply 3 over y to the second. We're back to having one base. We have 10 to the negative third. Again, it's a problem. We need to fix the problem. The way we fix the problem is by moving it to the bottom. We're left with nothing on top, so we keep that placeholder as a 1. And then by moving 10 to the negative third down, the exponent then becomes positive. 10 to the third power is 1,000. We can simplify it as 1 over 1,000. Now if we try to apply some of our multiplication properties, this is a power of a power. When we have power of a power, we multiply them, so we get 2 times negative 5. And 2 times negative 5 gives us 2 to the negative 10th power. Up until today, that was good enough. Now I've shown you how to simplify that, so we need to. We put this over 1, we move it to the bottom. Now, once we've moved it to the bottom and it's become positive, there's nothing on top, but we need to hold that place, so we put a 1. Looking at our next problem, now we have 2 base numbers. We know that this exponent distributes to both. And when we distribute it, it's the same as s squared to the negative second power and t cubed to the negative second power. Now we have our power of a power rule, and we multiply the exponents, so we get s to the negative fourth, t, and we get 3 times negative 2 is negative 6. Because these are both negative, we put it over 1. We need to move both of them down, because both of them have a problem. When we do that, the top is empty, so we save that spot by putting a 1 in there. By moving the s down, the negative 4 then becomes a positive 4. When we move the t down, the negative 6 then becomes a positive 6. Now looking at our last example, I'll move this over. Our last example, we have 3 base numbers. This exponent is going to go to all 3. Notice this exponent is positive, so we're still going to have 3 to the third, then a to the negative second to the third, and b to the second raised to the third power. We have a bunch of powers of power. 3 to the third is 27. Negative 2 times 3 would give us negative 6. And then 2 times 3 gives us positive 6. Now, like I said on the last slide, see this as 3 individual things. When we look at this as 3 individual things, what we're seeing is that really only one of these has a problem. The other 2 are fine. We're only going to fix the problem. The way we fix the problem is by moving it. We put this over 1, and we know that this a to the negative 6 has to come down. We're left with 27 and b to the 6th. Those remain on top because those are perfectly fine. But the a to the negative 6 moves down to become a to the positive 6th power. I hope that answered your questions and helped show you the basics of simplifying negative exponents. We really only focused on moving things down. Eventually, we're going to start getting into the division rules where we might actually have to move things up as well. But that'll come down the road. Good luck, and thanks for listening.